Right, I'd like to welcome everyone to tonight's talk at Denby Dale Amateur Radio Club, and a big welcome to local members of the club, but also international visitors and members of Denby Dale Radio Club that have joined us in the last 12 months. So hello to everyone this evening, and good to see you all. Tonight's talk, we've got John Burnley, NU0V. And I saw a couple of months ago, there was an article, a very interesting article, but very simple. And I thought appealed to me anyway, that John had written for the ARRL magazine QST on a simple DC polarity checker. And John was making the point in the introduction to the article, any of us that have been involved in the hobby for a long time, and I'm going to confess I'm one of them, has accidentally at some stage managed to blow up something by getting the polarity of what we're giving that radio the wrong way round. It's possible to do it. I've only done it the once. I will never do it again. Let me tell you that now, without John's assistance from his talk tonight. But it can be done, and I think it's quite a good idea to have something that's very simple and handy to and very cheap to build as well. So John, NU0V, John and I met because John is an active member of the QRP community and gave a talk at the GQRP Club convention, and John helped us in chairing some of the events at the GQRP Club convention last year. So John, I'm going to hand over to you. I've lost you for a second. And if you're unmuted, you can share your screen whenever you want.
All right, thank you very much, Nick. Can everyone hear me okay? I'm on a headset and okay, thumbs up, excellent. I'll go ahead and share my screen. And Nick, can you see the opening slide?
I can, yeah. I mean, I can see you've got it in the presentation mode, so we can see your blurb on the other side of it as well as the actual slide itself.
Okay. Well, that's why. Let me unshare, and we'll do it on screen too.
That's
How's
it.
That?
That's it. Brilliant.
I don't want to give away all the secrets. You can read ahead and know what I'm going to say. Well, first, thank you all very much to the Denby Dale Club it's an honor to be invited to speak. I teach for a living now and speak quite a bit, and usually my audience isn't all that interested in anything I have to say since they're students. But I am honored to be here, and I do thank you very much. I was, to be honest, a little concerned going into this morning. My internet dropped last night, and it was fixed just about an hour and 45 minutes ago. And so I was wondering if I was going to have to run things through a hotspot, or I was going to have to make a mad dash to get an alternate connection point. So I moved everyone's pictures right in front of what I was trying to do. All right. I'll tell you a little more about myself. I have over 30 years experience in IT, which was my primary occupation up until about 7 years ago. Prior to that, I was a radio announcer working at AM and FM stations in the Southeast and the Midwest. I now teach at Iowa State University, as well as Des Moines University. All of these are IT related courses. And I've been associated with amateur radio for over 50 years. It's hard to believe it's been that long, but I started very young and have enjoyed various aspects of the hobby, like many of you have, depending on the length of time that you've been in the hobby itself. But just a couple of pictures. My wife and I love to bicycle. We try to do 800 to 1,000 miles every summer. COVID has interrupted that quite a bit. I'm from the South, from Kentucky, and in Kentucky, we like horses and basketball. And the picture on the upper right has to do with Southeastern Conference basketball for the University of Kentucky. We love to travel a lot. In the lower right-hand corner, that's the Grand Canyon. What you can't see is my wife telling me to go one more step back. And she kept saying that, but eventually I caught on to that. And then finally, the center picture on the top row, one of the highlights that I've had over the last, over my hamming career, I actually got to operate Whiskey 1 Alpha Whiskey at the ARRL headquarters about 3 years ago. And that was an absolute treat. If you're ever in that area, I'd highly recommend, if you have a chance, to try and do that. It felt like rare DX. And people from Iowa generally don't feel like DX. So it was quite a different feeling. But I wanted to just talk to you a little bit about some of my early hamming days, setting the stage for what I'm doing now. When I first was licensed back around 1970, we were rock bound. And for those of you who are more recent to the hobby, that meant we were crystal controlled. Did a lot of DXing. I had a vertical and a 2-element Yagi. I was very lucky when I got into the hobby that we moved into a neighborhood where my Elmer, future Elmer, lived. Ken Distel, he's now Silent Key, but Whiskey Alpha 4 Alpha United Lima, and one of the best Elmers any kid could have at the age of 11 and 12. He helped me build a 2-element Yagi that we lashed literally to a wooden swing set in the backyard. And Ken introduced me to a unique method of aiming that Yagi, which we call it an Armstrong rotator. I don't know if anyone's familiar with that technique, the Armstrong technique. Everyone's kind of looking around. Possibly you do, but with the Armstrong technique, it literally is using your arm and giving it all the strength that you have with a pipe wrench. And I remember one winter when when I was trying to work some DX, absolutely love DX, and I heard Alaska and AL7 in the Aleutian Islands. I ended up working him, but it was during a winter storm, and the wind kept catching the 2-element Yagi and would reposition it towards Europe. So I had to keep running out with my pipe wrench and then turning that. But I'm sure that we all have a lot of good stories that we can talk about in the early days. Like a lot of individuals, I kind of came into the hobby, got away from it for a while, then would come back. And that all changed really in the 1990s, where my Elmer, Ken, WA4AUL, introduced me to this, what he called this QRP thing. And he goes, it's really pretty exciting. I mean, you're not running any power at all, and it works. You can actually, talk to people like you would running 100 watts, and I think you'd really enjoy it. And of course, I told him I thought it was nuts. QRP would never work. I wasn't sure about this. And then I tried it and ended up loving it. DXing is even sweeter. Running QRP, anytime you work that rare one, it's an accomplishment. But when you do it using QRP, it's just that much better. So I've got fully immersed in the QRP community. I co-founded the Iowa QRP Club back in the 90s. I ran their newsletter for a while. I then joined every QRP club that I could. GQRP, NorCal, Arctic, Northwest, New England, just all of them, and just couldn't get enough of QRP. And with QRP within that hobby, there's a lot of building. I had never really built anything literally until the 90s. But within that community, there's so many organizations, so many great organizations that not only from a commercial vendor standpoint, but from the clubs themselves that have all kinds of projects and kits that you can build. And so it really opened up a different aspect of the hobby for me when I got into building. And you can just see a couple of my projects, and these were kits. On the left is one of the Appalachian Trail series from KD1JV. It's the original one. And then on the right was a Night Smite. Both of these are surface mount, which is an interesting way to build as well. But with all the building that I've done and everything, and I only operate rigs now that I have built, but they've all been kits. They've all been someone else's design. And I had never ever really designed a board or really any type of circuitry whatsoever. But that all really changed in 2018 when I attended a local ham fest here in Iowa, and I met Barry, Whiskey Zero Italy Yankee, and when he presented on using KiCad, I've also heard it pronounced KiCad, which is a automation tool where we can do circuit board design and circuit design. So it was, I thought, a really good talk. And there was a project in the back of my mind that I wanted to get into. So that was my excuse to start designing. Now, the article that Nick mentioned, that's not my initial design. That design was based off all the mistakes I made on the initial design that I wanted to do. And one of the common themes that I had was that I kept wiring up these silly little barrel connectors wrong. For something so simple, I just kept doing it wrong. And I think I have one banner moment in my career as well with a NorCal 20 that ended up on the wrong end of the polarity. Now, if you take a look at, how many of you have at one time sat back and said, gee, I wish I'd thought of that? And most of these ideas are generated out of some need, but there's a lot of silly, simple little things that have really generated a lot of money for people. The Chia Pet was one. A smiley face was another. It made the creator of that symbol a multimillionaire. The person that thought up the little toy, behind the 8-ball. Also, just one of those little things that you kind of wondered, why didn't I think of that? And my all-time favorite happened to be the Post-it notes. And that's one of the things that I've noticed with a lot of creative ideas. It's not necessarily that the idea itself was original, but it's a different implementation of an idea that really made it unique. And so in response to my inability to wire things up correctly, I had my aha moment. And that's what led to the article, the DC power polarity checker. As I mentioned, I was really working on another project at the time, but just because of some of the things I kept doing, I went ahead and then went more for this design, which has ended up saving me quite a few headaches. With polarity, barrel connectors, or really any type of connectors, you can either wire those with a positive polarity, which means that positive is applied to the center pin, or you can do a negative polarity, which would be a negative on that center pin. Now, all the gear that I use and everything that I've built has been that center pin positive. But bear in mind that while that's my universe, and for this design, that's what it was geared for, there is equipment that does use center pin negative. So whenever you're checking polarity, make sure that you understand what the rig is that you have and what it's expecting for that polarity. Now, as far as the schematic for that, and this wouldn't be a presentation for me if I wasn't doing some type of drawing. Let me see if I can get to that. Can everyone see the version 1 schematic? Okay. This is how I drive my kids crazy in class when I teach at Iowa State. So it's really a simple circuit, and
we can't see the circuit, John. We can just see the title that says version 1 schematic.
I'm going to draw it for you.
Okay.
And let's see if I can. Now, bear in mind that I'm not well known for my drawing skills. So this is coming out, and center pin is positive, negative on the sleeve. We'll come to a momentary switch that comes down to a resistor, which then goes to an LED, and then back up for the negative connection. And I need to draw my line. Now, the way the checker works is that we also have a LED and sometimes my pen gets a little crazy. Comes in like this. So we have a resistor, an LED, so diode 1, resistor 1, diode 2, resistor 2. With positive voltage applied, this means that diode 1 is forward biased. It will conduct, and with an LED, when it conducts, then you will get some type of illumination. If you miswire, get those reversed. If negative is on the center pin and positive is on the sleeve, then diode 2 is forward biased, and then it will conduct. It also would then illuminate. It's actually pretty good for me. My kids complain all the time. I mean, and it's based off of just the simple properties of diodes. A diode, just a regular diode, if we apply positive voltage to the anode, negative voltage to the cathode, it is forward biased, and then it will conduct. Same goes for an LED, where if we do the anode, positive, cathode, negative, it will conduct, and it will then emit the light. Now, there are really two critical elements of the design, and that's the resistor and that's the LEDs. So when we're choosing the LEDs, there are two things you have to be wary of. First is the forward voltage, and then secondly is the forward current. So the forward voltage, this is the voltage, the drop in voltage that will go across the LED. And we will use that in conjunction with the forward current, then to calculate the resistor value that we need. And let me go back for just 1 second. One thing I forgot to mention is that these resistors, these are current limiting. Because if you've ever worked with an LED before without limiting the current, they will fail, and they will fail spectacularly, even to the point of potentially catching on fire. So we have to size the resistor appropriately using these two values. Now, if you notice on this chart, it gives you a range of 2.6 to 1.7. I've used both. For the article that was written, I think I used the maximum voltage. You can really use either one. There's not that big of a difference in the resistance that I think has a significant impact on this. So you could use either one. Each data sheet is different. Each data sheet does not necessarily contain all the information that its counterpart may. Now, this data sheet that you're seeing is for the green LED that was used in the checker. So when we go and we calculate that resistance, it's very simply, it's Ohm's law, in which we have the voltage divided by the current equals the resistance. In this case, the voltage that we'll be using is our source voltage minus that forward voltage drop that we got off of the data sheet. And then the current will be the current that's in amps. And remember that in most cases, the current rating will be in milliamps. And so you'll have to convert that to amps for the equation. So in our case, we have a 12-volt voltage source, which was the maximum that I wanted to use. It was 2.6. That's the value we pulled for the data sheet, dividing that by 30 divided by 1,000 to convert milliamps to amps. And it came up to right around 313 ohms. If you used the 1.7 value, it was 343 ohms. Now, you're never going to find a resistance that's probably exact. And we have a lot of standard resistance values that we can choose from. And the standard, the resistor standards that we have, those were created back in the 50s. And there are different scales that we can use, each one that is logarithmically related. Depending on the scale that you choose, where X is the number of resistances in each decade. In this case, we have an E6, there's an E12 that would have 12 resistances. There's an E24 where you could have 24 resistances. But the resistance that was chosen for the polarity checker was 470 ohms. And if you can see that we're using the 20% scale of the E6, that was the next higher resistance value in the decade. So for the ones showing, it's 10, 15, 22, 33, 47, 68. The next decade is 100, 150, 220, 330, 470, etc. The reason that they standardized on these values is to help manufacturers, so that what's being manufactured is comparable and compatible across all of the different manufacturers that make these components. So this is the original board that I created, and I used KiCad or KiCad for the design. It's a very simplistic design, as you can see. There are only 6 components to the polarity checker. The way that it operates is that you literally just plug in your barrel connector and then you press the momentary switch. And this again assumes that we have a center pin of positive. If it is the correct polarity, the green LED will light. If it is, excuse me, if it is the incorrect polarity, then the red LED will light. But after I built that, I was looking at the board, and you may not be able to see it, but there's something that's not quite right with this board. Does anybody see what's wrong with it? It's hard to see, I admit. What happened, and this was, again, with my being a novice at working with KiCad and doing circuit board design, but the little disclaimer, the copyright notice, I put it on the wrong layer, and so it's written backwards. And I was talking to my wife about that, and I told her that it was actually my intellectual property theft protection from reverse engineering. As you imagine, she didn't quite see the humor in that, but it's actually written backwards. So a lesson learned from that was that, make sure that you understand what layer that you're working with your design software. So it was back to the drawing board, and this is version 1 of the board. Actually, this is version 1.1 that had the copyright notice actually in the right place. And again, it works literally just as well as the other one. Same design, just put the lettering in the right spot. Now, if we go to the schematic, that was version 1 and version 1.1, and this design was back in 2019. And I'm always fooling around with these things, and it occurred to me that I could actually, and I don't think it won't let me erase it, but I could actually eliminate this resistor and this connection, and I could just connect the LEDs across each other and eliminate the resistor, because we need a current limiting resistor, but it can be either before the anode, or it can be on the cathode side. It doesn't matter. So leave it to me to design a 6-component circuit that could be improved by percentage-wise, probably a significant percentage. So that brought about then version 2 of the board. Version 2 using the 1 resistor that we have, and you can see operates just the same, just 1 less component. And so that was version 2 of the board. So all this was going on in 2019, and then we get to the spring of 2020, which, as we all know, has been problematic with our the pandemic that's going on. It led to a lot of isolation for most of us, even to the point of not being able to see relatives like we used to. I've been working remotely now for well over a year doing teaching. And it's during this period that the articles for QST were written, primarily because I became quite ill in the spring of 2020, where I had a 1-2 punch of a very severe infection, and which caused a lot of substantial pain. And I didn't know it at the time, but I was also passing a kidney stone. And so that led to about 3 weeks of bed rest. So I literally taught from bed for over 3 weeks. Now, it was remote, and as long as I had a dress shirt on and a good camera angle, the students had no idea what was going on. But it was during that time, because I was pretty limited in what I was doing, I decided to write the articles. And there's actually 2 articles. The first one is on, and if we have time, I'll show you that project, what it's about. It's scheduled to be published in July, I think, in QST. But I literally needed something to do, so I wrote the 2 articles, and the second was the polarity checker, and it actually is the one that got published first. And when I was thinking about what to do for the checker, I had several goals in mind for that. Well, first I had 2 versions. So number 1, which one do I write the article about? And so in thinking about how I wanted to approach the article, I had some goals. Number 1, it needed to be really easy to build. And I wanted it to be easy to build not only for someone my age who may be new to ham radio, but I was really interested in working with kids. And so I wanted to make sure that it promoted STEM, science, technology, engineering, and math topics, and that it was easy to build, and simply that children could understand it. But I also had a 4th goal, and that was to protect myself from my own misgivings. So like most things that we do in the States here, we always like to test our theories with focus groups. And so I put together a focus group of the probably the best representation I had of these 4 goals. And so my expert committee of 2, then I worked with to talk about the design, what made more sense, and which one that they thought would be really cool to build. And they unanimously voted for version 1. So that's the version that we went with. And you can see just a slight excerpt from the article in QST. If you ever have a chance to write an article for any type of publication, I really recommend it. It was a very good experience, and I learned a lot about their processes. And even if it's your local club, I think sharing your ideas is always a good thing. Now, with the checker, I put together some supplementary material. For those of you who some of you may have seen this, but I put together a spreadsheet that would calculate the values for you if you just wanted to make sure that your calculations were correct. And in the upper portion, I think you could probably see my cursor, or I can actually draw on it. But up in this area here, you enter the values from the data sheet, and it would calculate what the ohm values were for a precise measurement, and then the estimated dissipation in watts, because that's also a consideration with those resistance values. Not only that it limits the current to what you want it to be, but also that you size it correctly for power dissipation. And we also put into the spreadsheet a warning threshold. So if you wanted to be alerted, if it was within a certain percentage of the unacceptable range, to flag that with color coding. And then also we had the maximum dissipation in power in watts. So you fill all those things in and it generates the chart. Red means don't use it. Yellow means you're bumping up against the unacceptable threshold, and green meant that you were pretty much good to go. The spreadsheet was designed if you wanted to use exact values from your junk box. For the article and for the design, I've done some kits for it. Some people have asked for kits. I've used just one resistance value, easier to source, and again, the difference between using a 390 and a 470 ohm resistor, which is the one that we use, is not that great of a difference. If the eye won't detect any difference in illumination. Now, there is one thing that was interesting. I mean, the overwhelming response that I've had has been, very supportive and overwhelming. A lot of positive feedback. But like all things, you can't make everyone happy. And I did receive some feedback, which I thought was interesting. I did have 2 engineers that contacted me that were a little worried about the 2 resistor design. And what I should do is go back to that drawing, or if you remember what the design is, I hate to flail through that many, but essentially what they were suggesting is that because of the reverse voltage on the LED that was not being illuminated, it bears the brunt of the full source voltage, that it could potentially break down that junction, and you would see current flowing the wrong direction through the LED. The problem that you have is that the rating where you can do calculations to try and possibly figure that out, that's not a standard thing within the data sheets. And so I thought, well, you know what, why don't we take a look at this? And so I breadboarded the circuit and with the 2 resistor design, and you can see the results of that breadboarding. And what I did for the test, now, usually when you're using the checker, the duty cycle on that's very short, 2 to 3 seconds at most. But for my test to simulate this, I did a continuous duty cycle, and I was measuring the current going through, the green one is illuminated, so I was measuring current going through the red LED, and my voltometer measures down to the microamp scale, which was based on the calculations that from the feedback that I had received, where that should have been. And don't misunderstand, I was grateful for the feedback, because we're all learning as we go through this. So as you can see, there was no current going through the LED, and the only current that we had flowing was going in the proper direction, which illuminated the green LED, and the red one stayed unlit with no current. I ran that test for, and this is just a snapshot of my phone, I ran it for 2 hours and 10 minutes, 52.05 seconds. And that was with me sitting, I was working at the time, and I wanted to go ahead and monitor that just in case. And so I thought pretty comfortable that we could go ahead and repeat the test. But after the 2 hours, I switched, and the big difference is that I'm switching the power connections there. And so it illuminates the red LED fine. 20 milliamp was what I was expecting to see for that specific LED. So it didn't cause a problem with the LED, and there was no reverse current flow that had been that concern expressed to me. Well, from that, I thought, well, why don't we run it some more? And we can go ahead and be a little more confident in doing that in an unattended mode. So I hooked it back up and I ran it for the second test. And for that second test, then I ran it for 26 hours, 47 minutes, 21.08 seconds. And this is a continuous duty cycle. At the end of that time, I took this picture and I reversed the power, and as you can see again, it was the same results. So I thought, okay, so what did we learn from this? And converting the observations to predictions about what could happen on that original design. The assumptions I made were that duty cycle of 3 seconds, and that I can use continuous duty cycle to extrapolate an estimated life, and using the checker average twice per week. And the way that or the methodology I used for the calculations, the total time in seconds was TS. The total number of uses is the total time divided by the amount of time for one use, which was 3 seconds. So that calculation gave the total number of uses. Since I was doing it twice per week, I divided that number by 2 for the total number of weeks, and then divided that by 4, assuming 4 weeks in a month, to get the total number of months, and then divided that by 12 to get the total number of years. And this is assuming, again, standard time, 60 seconds in a minute, 3,600 seconds in an hour, 86,400 seconds in a day. And so my very unscientific results of this labor of love was that the total number of uses on the 2-hour test, if we use those results, I could use it at least 2,617 times. For the 26-hour test, I could use the power checker at least 32,000 times, 147. The total weeks, 1308 and 1607, 3. The months, 327 and over 4,000. and the number of years 27 and 334. So my very unscientific results about the potential of a problem with that 2 resistor design was that I wasn't going to worry about it a whole lot, because my very unscientific tests lead me to believe that that it was not anything to really be concerned about. And when I spoke with the technical editor at QST about that feedback, he initially told me that it's, from their opinion, it was nothing to worry about anyway. But I had 2 designs, and I decided to go ahead then, and going forward, we'll just stick with that 1 resistor design. But I had to tell the focus group, and the focus group was not amused. I do have a picture of them, but probably shouldn't share that, because they're not expressing themselves in probably a very diplomatic fashion. All right, so what's next? What's next for not only for me and my design work, but for the checker itself? So I've been trying to come up with different variations of this, seeing what other possible connectors that we can use. I have designed one for using Anderson power poles. This works very well. Not shown in this, soldering the power poles directly to the board as shown, I think provides enough strength, but there's also a staple that you can get, a special staple that actually loops over, and the board will accommodate that as well, which adds just a little extra security. Anderson power poles are designed to help prevent polarity issues, but it has to be connected to a power source at some point. And unless that power source has those connectors, then you still run the risk that that I had with doing the barrel connectors. And that's just another picture of that circuit board. Nick, how am I doing on time? I have some more things I can talk about, or I can start wrapping things up.
John, if you've got some more bits, go on, share it all, and then we'll throw it open.
Okay. And that's checker version 3. And so who would have thought a 6 and 5 component design would have 3 different versions of it? But what really led to this for the checker design was that the first thing that I tried to design a board for. And in 2017, there was an article in QST that had a web-enabled antenna switch. It was a receiving switch that the author used to switch one radio between 2 or 3 different antennas. And so I thought, why couldn't that be made so that you could potentially transmit on it? And so that was my goal, to do that. And so then I started working initially on my web-enabled antenna switch. And like all things, it started with a need. I wanted to have a switch to use in the main shack between different antennas, and I use balanced line. I wanted one that did balanced line, but I'd also thought about possibly incorporating this type of appliance at a feed point. I have a QRP guys vertical, and I wanted to possibly do something at a feed point so you could switch in various elements that changes the resonance of the antenna. But like all things, I got a little distracted. This is just the some of the essential points about that. I won't go into the schematic. Again, it's due to be published in July if things go according to plan. But it's based off of a microcircuit board that Adafruit sells, their Huzzah board, and it is Wi-Fi enabled. On the right, you can see just it's a simple application that was written, and with the application, the original design in QST was that you had to hard code in a URL in a browser. And so I took that software, I modified it. And so it was a radial button so that you could just point and click which antenna that you wanted, or in this case, I made it multiple rig and multiple antennas. And when you click on that, then the switch itself will tell you what radio that you're on and then what antenna that you're on. This is the first design of the board, and this is an unbalanced version because I was learning KiCad at the time, and you can breadboard certain elements of the circuit that uses a MOSFET to energize a relay, which then does the switching, which all can be breadboarded. But I wanted to start playing around with the design software and generating some boards. And with, there are just a lot of fabrication houses, especially some that are in Asia that are incredibly affordable. And so it gives you an opportunity to, create some boards, experiment, and if it's wrong, you're not financially impacted too bad with a design that didn't quite work out as planned. But this was the first version that I got working. As soon as I got it working, I realized that it probably needed to be a little more robust, number one, on the relays. This was the relays from the original design, which was more from a receiving standpoint. And I wanted to increase the potential of transmitting power because I didn't think the traces were quite robust enough. And again, this is an unbalanced version that I used. I did make another discovery too on this, in that when engineers tell you that a certain pin on the board should not be grounded when you boot, they're really serious about it. And as luck would have it, I had one of those grounded. I was trying to use it as one of the pins to energize the relay. And so I had to cut a trace and then reconfigure and use a different pin. So we had to install a jumper on that one. So that was a pretty good, I thought, learning point. Version 2 of the board never made it to production, because as soon as I finished that, I realized there's something else I wanted to change. So this is actually version 3. This one you could actually transmit at QRP levels. It should be robust enough. And yeah, you can see the Huzzah board here. And then these relays are just, they're a little more robust, but not outside of QRP levels. I wouldn't necessarily recommend it. And then the final design that you're going to see in the QST article uses a much more robust relay, as well as traces that can handle a little more power. Now, part of my problem is that I don't have all the testing equipment that I need to really, I think, get to an accuracy that I want. So I have to rely on some of my counterparts here in the area. And this also is an unbalanced line using coax, and I reused an enclosure that I had for an antenna switch that I had designed, a manual one I had designed back in the Iowa QRP days when I was doing the newsletter. That brings me back to my original need, the unbalanced line switch. Number one, to see if it would actually work. I thought I didn't see a reason that it could not be effective. And I've gotten as far as designing the board, but I haven't built it yet because I've been distracted with so many other things. Like most of you, the pandemic has caused quite a bit of chaos. From a teaching standpoint, it has really created a lot more work, moving things to online. And with online, as you might imagine, you have to keep mixing things up. because you can't have the same type of assignments, the same type of exams, because students like to share. And so there's a lot more work involved when you have, other than when you have more control when things are done in person. So some of the key insights that I hope that you take away from this. Number one is never be afraid to experiment. I saw, in fact, I was one of the moderators for Nick, and I don't remember Nick's last name, but he goes by, I think, Nick the Vic. His presentation really resonated with me at the GQRP convention, because like myself, he's not an engineer. And so he's experimenting, and he's trying to learn as he experiments, get better at the hobby, get better at designing. And I thought he really did a great presentation. And that's the spirit of what I've done with some of my designs. But experiment, don't be afraid to design your own stuff, not only from a circuit perspective, but your boards as well. And whatever you do, document it, write it down. Write down what worked, what failed, and lead up to, potentially sharing it with members of your ham community, either locally or through your local newsletter, or nationally through organizations like GQRP, or internationally. Actually, GQRP would be international as well. But write it and share it. If you thought that there was a need for something, I guarantee you that there will be a lot of other people who really feel the same way. And that's been my experience. The overwhelming response with the polarity checker was, the aha moment. Why didn't I think of that? That's, it's so simple, yet it can save you some headaches down the road. And with that, that's really everything that I had prepared for today. I hope that Nick, I used the time wisely for you. But do you have any questions at all?
Great, that was very good, John. I love the second design as well. So looking forward to that article. And by the way, John, we had Nick M0NTV speak here at the club a few weeks ago on his breadboarding work in building simple receivers and transceivers, and it was a good evening. So we do know Nick as well here at our club. Okay, I'm going to throw it out to. Can we stop sharing?
Yes, sorry
John,
about that.
and we can see the screen. Okay, who's got a question or a comment they want to make to John on his contribution tonight? Everyone's gone very quiet.
This is like being in class.
Yeah, that's right. Yeah, someone's going to go first.
Oh,
Hi, John.
I'll go first if you want.
Yes, go on then.
Okay, it's Brian Nuttall here, M0OYG. Thank you for a wonderful talk. I really enjoyed it. One of the things that I thought was very pertinent that you said was writing for QST magazine. I've been privileged on a number of occasions to write for Practical Wireless and Radcom on things to do with the Air Training Corps and their radio training, etc., and different expeditions. I've got to say, like yourself, very much enjoyed doing that. Despite having dyslexia, to be honest with you as well, but I really enjoyed doing that, and I really find it rewarding. So on all accounts, absolutely fantastic talk, and thank you very much.
no, thank you.
Lovely, thank you, Brian. Jeff, I think you were trying to get in as well. Yeah, Jeff, you're on mute. Need to unmute, Jeff?
Yeah, okay. Thank you very much, John, for an interesting talk. I think this is something very useful. Are the boards available?
Yes, I do have version 1 and version 2 boards available. The power pole I'm still playing around with, but I do have probably about 10 of those.
Okay. And that can be ordered through your qrz.com address or something.
Yes, I can put my contact information up quickly.
Okay.
It's NU0V at ARRL.net.
Okay. Thank you, John. Very good. Thank you.
Thank you.
Okay, thank you, Jeff. Anyone else with a question or comment to John on his contribution tonight? Yes, Roger.
Hi, John. Thanks for that. Interesting. I wondered if you'd considered putting a regular diode in series with the LED to improve its reverse in case you connect it to a much higher voltage than the LED could stand.
Yes, that's another method that you could use. Absolutely. And if you go with the one resistor design, the essentially the only voltage that the one that's reversed biased would be what's dropped on the LED that's conducting. But you could also, as you said, you could put an LED in series with that one, which would help with that. Absolutely. Or a diode, not an LED. Sorry.
Yeah, another diode. Yeah. And also, I wondered if you'd consider the fact that I've seen these little plug-in connectors, like center positive and center negatives in use, but there's dozens of different sizes. If you know, that's the other thing, in it, coping with all the different sizes of all the connectors for all the different bits of gear that you have. All the power,
Right.
Power bricks, you know, they're all different.
Yes, they are. The checker that I designed, Jameco, which is where I sourced the parts for that, they had 2.5 and 2.1 millimeter connectors that had the same footprint. I think that there are some others, but I would be surprised if there are an exhaustive supply that would meet that footprint.
Yeah, thanks.
But that's a great point. You know, most of the things that I have is the 2.5 and the 2.1 millimeter connectors.
Yeah, well, I've seen them with both, but also that there's different outer sizes and different inner sizes in multiple combinations. It's a nightmare.
Roger, of course, if you were to build it and you got all the female sockets, you could series wire them all in, couldn't you? You could have 10 on there, so that whichever connector you're trying to plug in, as long as you only plugged in one at a time, you're going to have the same result.
Yeah, that's why I wondered if you did a board with all the different popular connectors you could find. You only need 2 LEDs, but loads of connectors you plug in.
Yeah.
Oh yeah, absolutely.
I've got loads of power bricks, and it's awkward trying to measure them with a multimeter.
Yeah.
Well, and I think that's why I went wrong a couple of times. I wasn't measuring those.
Yeah.
Yeah, Roger, what you just said is what exactly occurred to me, because I have the same problem. You know, you get these power supplies you pick up in places, and trying to stick your multimeter on them to read the voltage and to see if it's the right way around is a fiddly little job. So being able to just plug it straight in and lights up John's green light or red light would be brilliant, wouldn't it?
Yeah, and if you do it with a lot of different, as soon as you're going to do a lot of different ones,
yeah,
10 different push buttons with 10 different resistors, you can start off at 20 volts, 12 volts, 5 volts, work your way down to see which lights up.
Absolutely. Oh, and the one thing I forgot to mention during the presentation, if both LEDs light up, you've got an AC supply.
Yeah.
Yeah, and you're going to have one of those, Roger. One of those bricks is going to be an AC output and not a DC output.
Well, I've got some.
Exactly. Yeah. That's for your railway set, I guess.
I've no idea where it came from.
Right. Anyone else got a question or comment to John?
From me, I would probably want to stand and see how loud.
Everyone's gone very quiet. John, I was very taken with the bit that you haven't yet published, but the web controlled antenna switch. I mean, again, a nice simple idea, and I'm amazed that there isn't such a thing commercially available yet. I haven't seen one, or is there one around?
To my knowledge, there's not one around. And the reason I did what I did, excuse me, is that the original design in QST hard-coded an IP address. I changed that for DHCP, which meant that you could use it either in your shack or you could actually use it out in the field if you have a hotspot. And so it added a little more versatility for what I wanted to do. But I have not seen anything commercially available for that.
There is a guy in Scotland around Glasgow area who's selling something similar, but certainly the first version is using an Ethernet cable, but does exactly the same thing.
Yeah, there's plenty of cable versions around, aren't there? I mean, that's right, Brian. There's plenty of versions on the cable, but not doing the switching over the internet.
Mm-hmm. Mm-hmm.
And of course, you know, most of us are operating radios in shacks with computers which are internet connected. So, you know, and people are using computers, of course, to control bits of the radio as well. So definitely, that's definitely a good idea, John, I have to say. Looking forward to you say July that's going to come out, you hope.
It's scheduled tentatively for July. Yes.
Okay. Incidentally, I've got a copy. I'm sure I'm allowed to do this, but I can share on the chat for people to download a copy of that QST article that came out. If I can just find it very quickly, just see if I can find it. Should be able to.
I was also thinking, John, it's just another idea to have a kind of a web-based system to let your antenna turning around. For example, for satellite work, that would be useful to have a small antenna that you can make available to turn around with web-based control. I don't know if that is existing already, but
Yeah, that I don't know, but yeah, that should be actually fairly, what I would think would be fairly simple. I mean,
yeah.
just even with the existing circuit design, because all you're doing is just enabling a relay.
Yeah.
What was I think people who are in astronomy or looking to the stars, and they have their cameras that can turn around on a tripod, and they are doing this with an app on their telephone, and I think it's a little bit the same principle.
Yep, I would
But you
agree.
can use that for having an antenna turning around.
Yeah, most of I mean, incidentally on that, of course, Jeff, most of the rotators nowadays come, when you buy the commercial ones, come with the remotes, so they've got infrared for turning it round. But there's absolutely, as you say, there's absolutely no reason, very simple, to control it over the internet.
Yeah.
And I'm pretty sure not just astronomers, but I think when Robin Mosley came and gave us the talk on his satellite controls, I'm pretty sure he was controlling that on the software on the computer.
Okay.
The direction of his antennas.
Well, these programs exist, like SAT32PC from the German guy, but you need cables. And sometimes that's a problem, to have cables to your antenna. It's more practical to have a web-based system, because the wife is not always happy to put some holes into the wall and so on.
Yeah, I've shared on the chat for anyone who wants to take a copy of it, a copy of John's article in QST. So it's there to just on the chat, just hit the download button. I sent it to everyone, and you can download it to your own device and read it in your own time. Okay, anyone else with a question or comment to John? I mean, I think we're all pretty similar, aren't we, in this room here? Sometimes a simple idea is sometimes the best idea, isn't it? And actually, the more complexity we add, the more it detracts from the elegance of the simple concept to start with. But I'm going back to Rogers. I think if I was to make your polarity checker, John, I think I might have maybe just 3 or 4 different connector sizes on a board. I don't think I'd go for a dozen of them. And of course, I would then find, Roger, your brick, which didn't fit any of the 3 or 4 I had there, of course. And then I'd be getting the multimeter out to check it.
Yeah, they do make adapters, of course. You can get these multi-pole adapter things that people use, but
Yeah.
that's a pain in itself. So
Yeah, because you lose all the bits.
yeah.
Okay. Anyone else before we say thank you to John? Anyone else got any comments or questions to John on either of his contributions tonight? No. If not, can we first of all show our appreciation to John for his talk tonight in the normal way that we do here in the club. So, thank you, John.
Thank you, John. Great.
Thank you all very much. I really enjoyed being here. It was an honor to be invited.
No, it was excellent, John. Very, very good indeed. And thank you very much. And if you haven't heard from him yet, I'm going to pass on your details to Rod, VA30N, who is running the Cycle 25 radio club from Canada, which has got adherence now from the States as well. So I'm going to tell the club a bit later about Rod's activities, but he'll be interested in your talk, I'm sure, John. So if you don't mind, I'll pass your details on to him.
Yeah, that's fine.
Okay, thank you very much, everyone. I'm just going to stop recording and we'll still be here.